In this video tutorial, we shall see program to add series of BCD numbers. Let us first see the logic of the program. So here I have considered a block size of 5 bytes, right? So these are the memory locations now. Now when you consider BCD arithmetic, the first and foremost thing is that you should give valid inputs. By valid inputs, the input should be a BCD number. Okay, so any number which is a combination of 0 to 9 is a valid BCD number, right? So here sometimes students do the mistake, they give invalid BCD number and they will be expecting the result in BCD which they will not get, right? For example, now 25H, this is a valid BCD number, right? And when you give the input, give it as hexadecimal only. Why? Because if you don't mention it as hexadecimal, what will happen is, suppose if I only give 25 in a register, so what the controller will do is, it will take the hexadecimal of 25 and it will copy to 30H, right? So I want 25H as it is to be copied to memory location 30H. So although it's a BCD number, I prefix it with H so that I get the same number. Okay, let me make you more simple. Let's say I want to provide a number 10. Okay, now if I only type 10, right, what will happen is, when you check the memory, it will be actually A, because we have given the input in decimal and the controller, that is the compiler, has converted into hexadecimal. So what do I need to do if I want the same 10 to appear in 30H? So along with that, if I give H, so the 10H will be copied to 30, right? So while calculating, while doing the addition, we will treat it as a BCD number only, right? So this is a valid BCD number. But if I give something A5, is this a valid BCD number? No, this is not a valid BCD number, right? But just visually seeing, you can say that this is not a valid BCD number, right? Let's say I have given the decimal input as 255. Is it a valid BCD number? No. Why? Because the hexadecimal equivalent is FF, right? So this is also not a valid BCD number, right? So that is the first thing. So 99H, definitely it's a valid BCD number. Let's say 67H, it's a valid BCD number. Let's say 78, it's a valid BCD number. Okay, and let's say 90H, it is also a valid BCD number, right? So we need to find the sum of all these numbers now. Okay, so first let us see what will be the sum. So all these are BCD additions, so you can use a standard calculator. 10 plus 99 plus 67 plus 78 plus 90. So it is equal to 344, right? So we expect this result, and in the BCD form only, right? Now what is the logic of it? The logic is simple. Add two numbers at a time, and after the addition of those two numbers, if there is any carry, you keep a counter which keeps tracks of the carry count. So whenever I get a carry, you increment that counter. So initially that counter will be equal to 0, right? So first I shall take the numbers 10 and 99, right? So how much is 10 plus 99? 10 plus 99, it will be 109, that is in decimal actually. So if you go to hexadecimal, so 10 plus 99, sorry, so 10 plus 99 is 109. So you got a carry of 1 here. So this will be 09, right? And because you got a carry, you will increment the count. Okay, we shall mention here. So carry is equal to 1. In the next addition, take the previous sum, that is 9, and add with the next number. The next number is 67. So it is 67, right? Now 9 plus 67, it is 76. So I have not got any carry now. So carry is 0 here. So I will not increment this carry count. So the previous sum is 76. So 76 plus the next number is 78. So now 76 plus 78, it is 154. So 54 and carry is equal to 1. So I will increment the count again. So this will become 2 now. I will take the previous sum, that is 54. I will add with the last number, that is 90. So 54 plus 90. So I got 144. So I got a carry of 1. So this will be 44. Because I got a carry, this will be incremented by 1. So the final result is, so the most significant digit is 3. And here are the 8-bit results. So the total result is 344, right? So that is what is the expected sum, right? So this is the logic. The same thing we shall write a program. So because we have an array of numbers, we have to have the count. Let's say move r2 comma hash 5. So this is the block size, right? And I need to have a pointer. So this is a pointer to the start address, right? So initially we shall clear accumulator, although it is cleared, and also we shall keep a counter for keeping the carry, right? So we shall have register B, so that also we shall clear move B comma A, right? So A will contain the result, okay, and this will contain the most significant digit, right? Although by default all the registers are initialized with 0, but still we shall continue the same, right? Then we shall add. So add A comma at the rate of R0, right? So add bytes, right? Now the most important thing is we are dealing with BCD, right? So when we are dealing with BCD, we want the result also in BCD. So for that we have to use the instruction decimal adjust accumulator. Now there are two things to be remembered while using the instruction decimal adjust accumulator. One is this instruction works only on the contents of accumulator. This is the first point. Second, this instruction should be used immediately after the add instruction. So these two things one should remember while using the decimal adjust accumulator, right? So I will say decimal adjust accumulator. So it will convert the result into BCD form, right? Now after this I need to check for the carry flag, right? Why? Because after every addition, if there is a carry, I need to increment the carry count, right? So what I will do is I will check for no carry, jump on no carry to skip. It means go for the next addition. But if there is a carry, I will say increment B, right? So I have performed the first 2 bytes addition. So the rest are left. So what will I do now? So I have to go to the next location, that is 31H. So for that I will do increment R0, right? And this will be repeated unless all the bytes have been over. So decrement jump on non-zero to repeat. So the repeat will be here. right? And at last you can end with the forever loop. Fine. So that's the program, right? So we shall execute this. We shall give the same input which we have considered. So there are 0 errors and 0 warnings. So we are already in memory location 30. So what is the data? 1099, 1099, 67, 78. All this is in hexadecimal. 78 and then 90. Okay, let us add. Let us see the first addition now. Right, the first addition is the first number plus 0, so we will not get anything but the same number, right? So first was 10. We can see 10 being copied, and there will be no change. Now it will be 10 plus 99, right? So we already have 10 in accumulator. Now R0 is pointing to 31H, which contains 99. So we are performing 10 plus 99, right? Now you can see the result now, right? So what we got is A9, but we want the result in BCD form, right? So once I apply decimal adjust accumulator, this result will be converted to the BCD form, right? So if you see, now see in accumulator you have A9, and observe the carry flag also. It is 0 now, but once I apply decimal adjust accumulator, A9 is nothing but 109, right? So once I do this, you can see we have 09 in accumulator and carry flag has become 1, right? So what should we do now? Whenever there is a carry, I have a counter to increment. Initially register B is 0, now this will be incremented by 1, right? So that's what we did in the logic here, right? Now to this sum, which is already in accumulator 09, I need to add the next number, that is 67. So for that I am incrementing the pointer here, right? And this will continue unless all the bytes are finished. Okay, so we shall execute all now step by step. Now 09 plus 67, it is 70 here. So once you apply decimal adjust, you can see the result as 76, right? So I will go on executing now. Execute the program unless it becomes, count becomes 0. So R2 has become 1 now, right? Now R2 is 1, it will become 0 now, and it has come out. Let us see the contents of accumulator and B. Accumulator contains 4 and register B contains 3. It means the sum is 343, which is in valid BCD form and which matches with our calculations what we had done, right? So this is the logic and the program of adding series of BCD numbers. Thank you.